So we're given a problem here that the limit as x approaches 0 for the function the absolute value of x over x. So the first thing we want to do in any limit problem is see if we can use direct substitution. Because we always want to see if we can just take the easy way out and just plug in 0 into the function to find our limit and see if that's possible before we do some additional work. So when we do that, we get the absolute value of 0 over 0, which gives us the indeterminate form 0 over 0. And this is the form that we don't like. We do not like this, because we can't do anything with the form 0 over 0. So in order to evaluate this limit, let's take the graphing approach and just graph it on this coordinate plane that I have over here. So if we graph it, we get a graph that looks like this. Okay, so if you wanted to find the limit of this, well, we know that from the right, the graph approaches this value over here, but then from the left, we approach this value over here. And since these values, it's approaching different values from both sides, we know that the limit does not exist. However, we're going to take a look at this phenomenon called a one-sided limit. So in this case, we do not have a limit. We know that because in order for a limit to exist, we must approach the same value from both sides. In this case, we're approaching different values from the left than we are from the right. However, in a one-sided limit, we're just looking at the behavior of the graph as the function approaches a value from the left versus when we approach something from the right. So the way we denote this is we have the limit of x approaching a constant from the left, because the negative sign means we're coming from the left. The negative side is always on the left, the positive side is on the right. So, as you might have guessed, the limit as x approaches the constant positive means that we're approaching it from the right. So in this case, we can evaluate the one-sided limits because we are approaching values from the left and the right. So in this case, the limit of x as approaches 0 from the left of this function, let's call this f of x, just for our sake here. As we approach 0 from the left, we can see that we're approaching the value of -1, and you can see that as we approach 0 from the right, we're approaching the value of +1. Okay, so we've evaluated the one-sided limits. Now we can come up with a reason for limits of when they exist and when they do not exist. So we can see here that the one-sided limits are going to be different, and therefore we see that we do not have a limit here because the one-sided limits are different. So we can formulate and we can infer that a limit can only exist if and only if the left and right limits exist. So we have a limit as x approaches c minus, we have a limit as x approaches constant positive, are equal to each other. Let's circle this. If they're equal to each other, and of course if they exist, and if they exist. Put that in parentheses. So once again, we can only have a limit if we have two one-sided limits. So we can't be approaching infinity because we don't have a limit there. If we have two one-sided limits, which we do here, but they have to be equal, which they are not. So that's why the limit for this particular function does not exist, because even though there are one-sided limits, it is approaching a value from the left and from the right. They're not equal to each other. So therefore, we do not have a